Thanks, Sam, and thanks everyone for attending this webinar. Today we will discuss two common types of changes that administrators may implement for the Smart IT ticket console, adding custom columns and changing the row-level security algorithm to Subquery. We will start with a review of the design of the data source used by the ticket console and the forms and workflow that enable us to add custom columns. A quick demo is included that shows how to add a column, and we will then discuss some common issues that are reported during or following the implementation of such changes, and recommended steps to prepare the implementation to avoid such issues. Next, we will discuss what is needed in the system to enable the subquery algorithm for the ticket console, the additional database views it requires, and how these can be generated. Several common issues that are reported when implementing subquery for the ticket console will be reviewed, as well as the steps that can be taken during the preparation to avoid these. We will finish up with some references that you can use to perform further research on these topics on your own. First of all, we're going to take a look at the way the Smart IT ticket console retrieves its data. Having this knowledge should help to understand how customizations affect the system and what to look out for if there are any issues with the display of data in this console. The Smart IT ticket console brings together the data of up to 8 ITSM request types, with their data stored across separate forms in AR system. So we need a mechanism to bring the data of these forms together. For this, Smart IT uses an AR system view form called SMT Union Smart IT Ticket Console, and this form is built on top of a database view that combines the data from the individual request forms. In the form list of Developer Studio, you can find the SMT Union Smart IT Ticket Console form, and it will show all the fields that we want to expose as columns on the ticket console. If you then check the view information in the properties of these fields, you can see it is based on a database view called U Smart IT Ticket Console and the name of the column in the database view that the field will retrieve its data from. Here you can see a few examples of various fields and the column names they map to. If you would then go to the AR system database, you can query that view and see that it will return data for the various ticket types, incident, work order, change, and so on. So now let's have a more detailed look at this database view and how it provides access to the data from the underlying request forms. On database level, at the top we have the U Smart IT Ticket Console view, which needs to provide access to the data of the request forms at the bottom of the screen. In AR system, each regular form will have an associated table in the database in which it stores its data. These are generally referred to as the T tables, as their name is always T appended with a schema ID for that form in AR system. The slide shows the names of the T tables for these forms on my system. As a first step, individual views are now built on top of each of these T tables, and each of these views provide a mapping for all the columns that we need on the ticket console to the relevant field on the request forms. The view for example, the work order form will be named U Smart IT WI work order, and if we look at a small part of the select statement in more detail, we can see how field with ID 164 on the work order form is mapped to the priority column, 182 is mapped to the ID column, and mappings are provided in this way for each union field. Now there are of course fields that are specific to only some of the request forms. For example, risk level is only used for change and release requests. So while the other request forms have no data to display for that field, their view will still include it as a column as highlighted here, but it will not be mapped to a field, and it will just return a blank value for request from that form. Similarly, for incident, a view named U Smart IT HPD Helpdesk is created, and you can see that the ID column in this case is mapped to a different field ID on this form as compared to work order. Again, risk level is returning no values as it does not apply to incident. Change request as a last example, the view is called U Smart IT CHG Infrastructure, and here we can see that risk level is now mapped to an actual field ending in 180, as risk level is applicable to change requests. Individual views now exist for all involved request forms, and the remaining names can be seen on the right-hand side. These form-level views all have the exact same number of columns in exactly the same order. The top-level U Smart IT Ticket Console is now defined as a union all of the form-level views, thereby combining the data of the request forms. So here we have an overview of the main design behind the database view that supports the Smart IT ticket console, as well as the objects it depends on. One last important thing to be aware of is how this architecture handles selection fields that hold similar type of data on the various request forms, but have a different set of selection values on each form. A good example of this is the status field in ITSM. We can see that the status field on, for example, the work order, incident, and change forms may have some overlapping selection values, but also many selection values that are specific to each request type. These fields also use the same ID range to encode different selection values, and it's these IDs that get stored in the database rather than the actual selection values. Of course, we don't want to have multiple different status columns on the ticket console. So in order to resolve that, the SMT Union Smart IT ticket console has one field called Consolidated Status, which includes all possible status values that exist on the underlying request forms. Each status value with its own unique ID assigned. To make sure the correct status value now displays in the ticket console for each request, the form level views that we saw earlier include code to translate the ID stored in the request form to the ID of the matching selection value on the ticket console form. The example given here is again for the work order view. The highlighted part shows how a case statement in the SQL maps the IDs for the source table to the IDs used for those selection values on the ticket console form. This then covers the basic design and involved objects that support the ticket console. What we will look at now is the mechanism the ITSM application provides to customize the columns of the ticket console. The SHR Union Configuration Console form is the interface in mid-tier where we can go to build or rebuild the database views. At the top, you need to select the implementation area for which you need to build the view, which in our case will be the Smart IT ticket console. The table at the left top then shows the list of the ITSM forms of which we want to combine the data in the database views. The table to the right shows the list of column names or union fields we want to make available in the database view. The table at the bottom shows all mappings that are defined, linking any source field we require from the ITSM request form to one of the defined union fields. With the bypass enum value conversion checkbox at the bottom, we can tell the workflow whether to build case statements for fields that require conversion, like we saw for the status field, or bypass that and just map the field without any conversion. Finally, with the Build/Rebuild Database Union Structure button, the workflow can be triggered that will rebuild the form views as well as the U Smart IT Ticket Console view that combines those form level views. During that flow, the workflow will pick up one registered ITSM form at a time, starting here with the HPD help desk form. For that form, it goes through a list of registered union fields, checking for each union field if a mapping is provided to a field on the ITSM request form to understand what SQL should be added for that union field. So either a mapping to a blank value or a mapping to a specific field on the form, including a case statement if conversion is required for that field. When the correct mappings have been determined for all union fields and the select statement for the view is complete, it then proceeds to drop and recreate the form level view in the database. The workflow then moves on to the next form and performs the same loop again over the union fields to create the mappings and eventually the form level view. When all registered forms are processed and all form level views are built, the workflow will then drop and recreate the U Smart IT Ticket Console view. Once that last step is taken, the status will be reported back in the user interface to confirm if the rebuild completed successfully. Using this functionality, adding a custom field as column in the Smart IT Ticket Console view is now as simple as adding a record in the SHR Union Data Source Fields form to register the new custom column name or union field, then adding one record for each request form of which we need to map the new union field to in the SHR Union Data Source Fields Mappings form, followed by a rebuild of the database views. So let's now take a quick look at a demo that shows how a custom column is added to the ticket console using these steps. Say we want a custom field, in this case a selection field named custom column, to appear as a column in the ticket console. To be able to select and add a custom column in the Smart IT Ticket Console, it has to be present as a custom field on the SMT Union Smart IT Ticket Console view form first. To be able to add the custom field to this view form, the column that will support the field needs to be present on the database view SmartIT Ticket Console. So the first step that needs to be completed is to recreate this database view to add the column. Once it is present in the database view, we can add it to the view form, and finally, we can add it to the SmartIT Ticket Console. In Developer Studio, we can see the custom column selection field on the infrastructure change form with 3 selection values with enum IDs 10, 20, and 30. And we have change request with ID 22 that has this field set to value 1. To add this field as a column on the ticket console, we first go to the SHR Union Data Source field form to register the new union field. We select New Request and add the following data. For implementation area, we select SmartIT Ticket Console. The unique union field name or column name for the view form is set to Custom Column. The union field type is set to 6 as we are adding a selection field. For this example, we also set the Convert Enumerated Values checkbox, as we will add the selection field on the ticket console with different enum IDs for the selection values. Then we save the record. Next step is the required entry in the SHR Union Data Source Field Mappings form to map the new union field to our field on the change request form. Again, we choose SmartIT Ticket Console as implementation area, set CHG Infrastructure Change as the source form, select our custom field called Custom Column, and finally we add the new Custom Column Union field name to map the field to and save the request. If we then move to the configuration console, we can see the new field in, for example, the field mappings table. If we would now simply choose to rebuild the view, we will see an error, as the field is not present yet on the AR view form. So the workflow is unable to map the enum IDs from the change form to enum IDs on the SmartIT Ticket Console view form. The right step is to first build the view without this conversion by selecting the Bypass Enum Value Conversion checkbox and then rebuild. We receive a success message, so now the field is available as column in the database view, and we can proceed to add the field to the AR view form. Back in Developer Studio, we create a form and view overlay for the SMT Union SmartIT Ticket Console view form. Then we copy the field from the change form and paste it on the view form. Make sure the column name in the view properties is updated to the correct value, custom column. Set permissions as required. To demonstrate the enum conversion, the IDs for the selection values are updated to 300, 200, and 100, and then we save the form. With the field now present on the view form, we rebuild the database view once more without the bypass enum conversion option selected. The final steps are then in SmartIT. If the custom field was only just added to the change form, go to the SmartIT screen configuration and refresh the metadata for the change view. Then go to the ticket console, open the Change and Order Columns dialog and select Refresh Metadata. We can now see the new custom column available for selection, and we can add it to the console. It also shows that the enum conversion is working, as it displays the expected value of value 1 for change ID 22. So this shows how it should work when all steps complete without errors. However, if issues do occur when implementing such customizations, it can cause the SmartIT Ticket Console view form to become unavailable, impacting the application and possibly the support staff, as frequently used functionality in SmartIT will stop working. The most obvious area being the SmartIT Ticket Console itself, which may start showing an SQL error and no longer display any data. There are also other parts of SmartIT that use this form to retrieve some of its data and may stop working. For example, the updates feed on the SmartIT dashboard is no longer populated, and the activity feed in requests could be missing. So let's take a look at some of the most common errors that are being reported as well as possible ways to prevent or minimize these. The first example is an SQL error when opening the ticket console, indicating there is an invalid column name, in this example, for the custom column. This error suggests that the SMT Union SmartIT Ticket Console view form has a field referencing a column named custom column, but this column is not actually available on the database view that supports the view form. Such errors normally happen when data in the Union Data Source fields form inadvertently changed, maybe by accident or during testing, and Union fields that the AR view form depends on are no longer defined. Such issues will not be noticed during the rebuild of the database view itself, but only once the SmartIT application is used. The reason for this is that the workflow that builds the view only considers the Union fields defined in the data source fields form. There is no automatic check that makes sure that the records are provided for all columns the AR view form already depends on. The solution in this case would be to add the Union field back in the data source fields form and rebuild the view once more. Another common error is this 48747 error when attempting to rebuild the views. This can occur when there are Union fields defined that have the Convert Enumerated Values option selected, and the field on the SMT Union SmartIT Ticket Console view form is missing one or more of the selection values that are present in the map fields on the request forms. This can happen if a new value is added to the selection field on one of the request forms, say value 4 on our custom column field, but a selection value is not added at the time to the field on the Ticket Console view form. Or maybe definitions for one of the request forms or the Ticket Console view form itself were imported from another environment and resulted in such a mismatch of selection values. To resolve such issues, we need to make sure the fields on the view form include all possible selection values of the fields it is mapped to on the request forms and rebuild the view again. Finally, a last common SQL error when accessing the ticket console is where it indicates a problem with the union all that should combine the form level views. Usually this happens when an error occurred during the last rebuild of the database view that was not corrected or went unnoticed. As discussed before, the top level view combines the form level views using the union all operators. For this to work, the form level views should all have the same number of columns, and they should be in the same order. During a rebuild action, Workflow drops and recreates one form level view at a time, before moving on to the next form. So say we are adding a new column during our customization, and the views for help desk can work order rebuild successfully, but an error occurs during the rebuild of the change related view. The new column has already been added to the first two views at that stage, while the remaining 6 views have not been updated and remain as before. This then causes the union all to fail, as the number of columns in the form level views no longer match. To address this, re-trigger a build of the views to check for any error that may need to get fixed. In case no error occurs during the rebuild, check to see if the rebuild fixed the issue. Of course, rather than resolving errors during or following a database view rebuild, the preference would be to minimize the chance of such errors by making sure the field configuration is correct, especially as solving the errors that were just shown could become an iterative process, as only one error is reported at a time during a rebuild, so a next error could show up after fixing the first issue. So let's go over some steps we can take to prepare for a successful implementation. The first step would be to assure that all columns used by the SMT Union SmartIT Ticket Console view form on that system are defined and enabled in the SHR Union Data Source Fields form. To help with this step, a knowledge article has been created that includes SQL that queries AR Systems metadata tables to retrieve all columns used by the fields on the Ticket Console view form and checks if it can find an enabled record for all those fields in the Data Source Fields form. If union fields are found for all used columns, this SQL should return no records. In the example here, we can see that it detects that field ID ending in 948 on the Ticket Console form depends on a union field called custom column, and that this is not found in the data source fields form. So this should then be reviewed and proper records added before a rebuild should be performed. Once we have confirmed that all required union fields are defined and the previous SQL returns no records, the next step would be to assure that for the union fields that are marked for enumerated value conversion, the map fields on the Ticket Console view form contains the selection values of all fields it is mapped to. SQL provided in the knowledge article can again be used to help with this. It targets union fields that are set up for enumerated value conversion and checks in AR Systems metadata if the selection field on the ticket console view form indeed contains the selection values of all the selection fields on the request forms it is mapped to. Similar to the first check, this SQL should return no records in case the setup is correct. In the example output here, we can see that the SQL returns 3 records. For the Consolidated Status recent union field, it detects selection values on the help desk and change forms that are not on the ticket console view form. And for the custom column union field, it detects a value 4 selection value on the change form that is not present on the ticket console view form. Therefore, before triggering any rebuild, it needs to be decided whether these selection values should be added to the field on the ticket console or otherwise removed from the map field on the request form. These checks should help to prevent most common issues that are reported during and following a rebuild of the database views. Next to this, it would also be a good idea to test the existing database views first and then take a backup of their definitions before triggering any rebuild, especially when planning an implementation on a production system. This way, the views could be restored in case application issues are seen directly following a rebuild. If that step would be required, the recommendation would be to capture a rebuild of the views in API SQL filter logging first, before performing the restore, to allow for troubleshooting afterwards. The list here shows again the views in the AR System database that will be dropped and recreated during such a rebuild action. Finally, when adding additional fields as columns, these will become available for the user to filter on in the ticket console. Therefore, it would be good to also consider if the field may need to be included in a database index to assure queries from the ticket console on that field perform well. Next to adding custom columns, another change that is frequently implemented for the ticket console is changing the row-level security algorithm to Subquery, with the aim to improve performance for the console. Earlier row-level security algorithms used data stored with the main request data in the T-table of the form to check for user access to that record. For example, when a restricted user searches the incident form, that user's login ID, groups, and roles will be checked against data like submitter, assignee, and assignee groups stored in the T-table of the help desk form to see if the user should have access to that request. Starting with version 1902, a new row-level security algorithm is available called the Subquery algorithm. This algorithm requires a new separate S-table that specifically stores the row-level security-related data for each request. It uses a similar naming convention using S and the involved form schema ID. For example, records in the S-table for this incident would have data like this, with multiple records for the incident's entry ID, and with labeled ID containing the field ID that the permission stored in the label value column relates to. This S-table is then accessed as a nested query of the main query against the T-table to check the user's access to a record, joining the C1 column of the T-table with the entry ID column of the S-table. For regular forms in AR System, the administrator can select Enable Security Table in the form definitions in Developer Studio to have AR System create and populate this S-table, as well as selecting whether to use the Subquery algorithm for that form when evaluating row-level access. For AR View forms, AR System does allow the administrator to enable the Subquery algorithm, but there is no option to create the S-table, and it expects that whoever created the view form will also make sure the equivalent of the S-table for that view form exists before enabling the Subquery algorithm. As the SMT Union SmartIT Ticket Console form is a view form, filter workflow was introduced that can build an S-view in the database to support the Subquery algorithm. This S-view is built on top of the S-tables of the individual ITSM request forms, using a similar structure as for the main data views. This filter workflow executes on a service call, which can be initiated either by using the same build-rebuild database union structure option on the Union configuration console that we saw earlier, or via a utility that ships with AR Server 1908 and higher, which is called AR-RLS. In the next slides, I will first discuss building the S-views using the configuration console. After that, I will also quickly show how the AR-RLS utility can be used to trigger the build. At the bottom of the screen, we have again the ITSM request form the ticket console combines. For each of these forms, we can select the Enable Security Table option in the Form Properties in Developer Studio to have AR System create and populate the S-tables. Once that process has completed, a rebuild of the database views for the ticket console can be triggered from the Union Configuration Console. This will always first initiate a rebuild of the main data views that we saw in the initial part of this webinar. And if that completes without errors, in 1902 and above, Active Link Workflow will initiate a second service action to build or rebuild the S-views for the ticket console. Only if existing S-tables are found in the database for all ITSM request forms the console uses, will Filter Workflow create the S-views on top of each of those S-tables. These views are then again combined using union all operators into a view called S Smart IT Ticket Console. Finally, to meet AR System's naming requirement for the S view, Workflow creates one final view on top of this, which includes AR System Schema ID for the Ticket Console view form, which on my system resulted in a view called S2216. If you are indeed intending to enable the subquery algorithm for the Ticket Console, please take good note of the exact message that is displayed in the configuration console once the rebuild finishes. In case you see the message Build Rebuild of Database Union Structure Complete, this implies that only the database views that were discussed in the initial part of this webinar were created. No S views will have been built. Only if you see the message Build Rebuild of Database Union Structure Complete with RLS view, then the S views will have been created or recreated by Workflow. Now let's review some common issues that are reported when Subquery is implemented for the ticket console. The first example is an SQL error that users with restricted access could see when opening the ticket console, indicating there is an invalid object name, in this example S2216. To understand which form this error relates to and what corrective steps to take, we need to check in the AR schema table for the reported schema ID using a query like this. In case the form returned by the query turns out to be the SMT Union Smart IT Ticket Console, it would suggest that the S views were not built, or at least not fully built, and we would need to go back to the configuration console, trigger a rebuild, and confirm any success message includes the with RLS view part. If the schema ID in the error relates to one of the ITSM request forms, this would suggest that the S view for the ticket console was likely built successfully before, but that afterwards the security table option for the ITSM form that relates to the reported error was disabled and its S table dropped. This could, for example, happen when a form overlay is important from another system that did not have this security table option enabled for the form, in which case AR will drop the S table. To address that issue, enable the security table again on this form via Developer Studio, and once that process is completed, check if the error is no longer seen for the restricted user. Another error users with restricted access permissions may see after enabling the subquery algorithm on the ticket console is this error, referring to an invalid column name entry ID, which points to an issue with the form properties of the SMT Union Smart IT Ticket Console. For regular AR forms like work order and incident, the S-table's AR system builds look like this, and the join between T and S-table is made on the C1 column of the T-table and the entry ID column of the S-table. The S view that is built for the ticket console is slightly different, and the entries for the above incident and work orders in that S view would look like this. The request's ID is in a column called Request ID, and there's an additional column called Form Name to include a reference to the form the entry relates to, as the view combines data of multiple forms. The join between S and T view should now be made on the combination of the request's ID as well as form name. For AR System to be able to do this, a special form property exists that tells AR System which field on the SMT Union Smart IT Ticket Console form contains the request's ID and which field has the form reference. This is not a property that can be set from Developer Studio, but can be seen when exporting the view form as a definition file. In the object prop list, this 60081 property should be present in both the base form definition as well as the overlay in case an overlay exists. The property includes the two fields that tells AR System which fields from the ticket console view form to use in the join. And in SQL logs of a working system, it can be seen that it joins on the columns of those fields. There are no cases where the 60081 property is not set as expected. Either it is missing from the overlay object or from both the overlay and the base object. In such cases, AR system will attempt to join similar to what is done for regular forms between the entry ID and C1 columns. However, as the SView does not contain an entry ID column, the invalid column name error will be thrown. To resolve this issue, a delete and recreate of the overlay would normally address the issue if the property is only missing from the overlay object. In case the property is also missing from the base object, the view form may need to be imported from another working system or work with BMC support in adjusting the definition file to add the property. Now, next to the Union configuration console, there is also a utility called ARRLS that can be run from a command line to create the SView and enable the subquery algorithm for the ticket console. The utility ships with AR Server 1908 and higher and is located in the AR Tools folder on the AR server. To enable subquery for the ticket console, you can then create a simple text file with the name of the view form like this, and then use that as an input file for the utility in a command with this format. When this command is executed against the administration server, the utility will find the request forms that are registered to be used in the ticket console, and for each it will check if the subquery algorithm is already enabled, and if not, it will enable it and create the S table. It will then also trigger the service call to trigger the filter workflow that builds the SViews. And finally, set the subquery algorithm on the ticket console view form and finishes the execution. Be aware that when the utility completes, the migration of the data to the S tables may still be in progress in case new S tables were created for one or more of the ITSM request forms. And as the subquery algorithm will already be enabled for the ticket console view form, restricted users may not see all expected data in the ticket console until that migration has completed. So finally, let's go over some steps you can take to prepare for a successful implementation of the subquery algorithm. First of all, as the required SViews are built on the top of the S tables of the ITSM request forms, we should review the setup of those forms in case the build is going to be triggered by the Union configuration console. Check in Developer Studio that Enable Security table is selected in the definitions of these forms. We also have a knowledge article with SQL that can help to quickly build queries to check for the existence of the required S tables for all ITSM forms that are registered for the ticket console. The output of that query would include a select statement for each ITSM form that can then be used against the database to confirm if that S table exists. Also, if security tables were just enabled for one or more of the ITSM forms, check the RLS migration pending form in mid-tier to assure the S tables have also been fully populated. Another quick check that can be made is to export the SMT Union SmartIT ticket console form from Developer Studio and assure that the 60081 property is present. Make sure to check for both the base and overlay object. As mentioned earlier, if you use the Union configuration console to rebuild the SView, this will also rebuild the main data views that were discussed earlier in this webinar. Therefore, the preparation steps mentioned in that section should be performed as well. Checking the setup of the Union fields and their mappings, assuring that all selection values are present for Union fields that use a numbered value conversion, and so on. Then, when performing the implementation using the configuration console, make sure that the with RLS view message is present when rebuilding the Union views, as this confirms that the SViews were built. Finally, once the subquery algorithm is enabled for the ticket console, make sure to include user accounts with restricted access when validating the system following the implementation. As for users with unrestricted access or AR administrator access permissions, row-level access does not come into the picture, so you would not be testing the SView structure, and errors may only start to show when normal users access the system again. This concludes today's presentation. For further details on the topics discussed in this webinar, I've included several references on this slide. The first link is to a section in the main SmartIT product documentation that again includes the process of adding columns and also has additional details in case, for example, localization is required. Then the second link is to the ITSM product documentation on extending the overview console. As the overview console shares the same framework to build and rebuild its database views, this documentation includes further background details on all the configuration forms that are involved. Knowledge article 233131 that is next in the list handles the steps again to add a custom column to the console, and the SQL that was discussed during this webinar to perform the pre-checks for the union field setup has been added to this article. Article 366961 has the detailed steps on how to enable subquery algorithm, and also includes further details on what to check to monitor the migration of the permission data to the S-tables. The SQL that was discussed that can generate the queries to check for the presence of the S-tables for the registered IDSM forms is attached to this article. The link after is again to the product documentation and has the details on the use of the ARRLS utility to help set the subquery row-level security algorithm. Finally, the last link on the page is to an earlier webinar with lots more background information on row-level security in AR system, the available algorithms, as well as troubleshooting steps. In summary, we started this webinar with an overview of the design of the data source for the Smart IT Ticket Console, as well as the UI and workflow that is available to configure this data source to add columns. For version 1902 and higher, the new Subquery RLS algorithm is available, and we show the design and how we can build the required S-views that support this algorithm for the ticket console. Finally, for both types of configuration changes, we discuss common issues that are reported during or following the implementation, as well as recommended steps to prepare for such an implementation. So please visit the BMC community at community.bmc.com, and if you had a question today that did not get answered, feel free to ask your question to the peer support channel on the communities. Thanks again for attending today.